Alright, what is up my homies? Welcome to Brainmelt University. Today we're going to be talking about VLANs, the VLAN Trunking Protocol, and the Dynamic Trunking Protocol. I see this all the time, especially with beginners or people who aren't quite sure what these two protocols do or how they relate to VLANs, where they tend to believe that these are the same protocol or they tend to operate in exactly the same way, but that really couldn't be further from the truth. If you find this video helpful, please feel free to like, subscribe, hit the notification bell, share your comments and concerns down below in the comments. All of these things help the YouTube algorithm, which helps recommend us to more viewers and helps us become a better resource to you in the future. With all that out of the way, let's get started. So one of the major pet peeves I have is that people who are not new to networking generally are getting their knowledge from one of three areas. This could just be a random YouTube video from some Joe Schmo who calls himself Brainmelt University. This could also be some sort of online help documentation, which really could be way above a person's head if they're just starting out with networking, or they're going to be getting this information from help forums. They could also be getting this from an actual networking textbook. This is pretty common when you're taking formal classes to learn about computer networking. Or this could just be someone who's attempting to self-teach themselves so they can pursue a certification, and they're just buying a certification guide off of some online source like Amazon or eBay. When it comes to discussing these three topics, they either spend an inordinate amount of time discussing VLANs and not enough time discussing DTP and VTP, or the much more common mistake I'm seeing in these textbooks and cert guides is that they will combine DTP and VTP into a single section of a chapter, which kind of goes to make people believe that these are the same protocol or they're used for the same thing. In one example, I found a certification guide that has a bold header saying that the next section is going to be about VTP, and the entire section was just discussing DTP port states. This is a huge problem when you're first starting out, and that's why today we're going to be discussing what DTP is, what VTP is, and how both of these apply to the concept of VLANs. Let's take a real-world scenario. Say you have a company in an area of your building. There is a dozen people working in the sales department who are all connected to a 24-port access switch. Your company, for many reasons, might decide they want to move a dozen people from the marketing department into that same area so that they can better coordinate with the sales division, and also to maybe cut down on operating expenses by having those two divisions both operating in the same area. Now, even though the marketing and sales divisions might be very similar and have a need for many of the same resources, both of these groups of people should be on separate networks. You really shouldn't have a person who's in the sales department have access to marketing resources and vice versa, so you need to keep these two networks separate. Now, the old school way of doing this, and I'm talking like 1980s, early 90s old school, is you would actually take all of the switching infrastructure from the marketing's old location and move it to the new one. You would have separate access switches feeding both of these groups of people, and you would have separate cabling connecting them all to the distribution layer.
Ain't nobody got time for that.
However, this is completely unnecessary when we take into account virtual local area networks. The idea of a VLAN is you have a 24-port switch and only half of those ports are being used by sales, so why don't we just split that switch into two logical switches and create one half for the sales division and the other half for the incoming marketing division. Both of these will still have access to their old networks, and both of them will be completely separate for the purpose of segmentation and security. This is what a VLAN is. VLANs are normally numbered between 1 and 4094. This gives you a lot of different options, but let's say this is not a small company that just has a sales division of 12 people and a marketing division of 12 people. But say this is a multinational corporation that has offices all over the world, and these offices all have multiple different departments working within them. This means that even though configuring VLANs is still going to save you a ton of money on physical hardware, but it's also going to create a little bit of administrative overhead as you have to separate these switches out and put different interfaces in different VLANs. This is normally an acceptable risk, and using VLANs is a very common practice, if not universal practice, when it comes to networking. But that access switch that's feeding both these sales and these marketing people still needs to be able to pass both of those network traffic up to its respective distribution switch, and that distribution switch needs to be able to pass that information up to its respective core switch. So this is why we have to differentiate between access ports and trunking ports. An access port is simply a port that provides one end device with access to a specific VLAN. There is an exception to this rule, and this is in the case of voice VLANs, where you might have a voice over IP phone rigged up between that switch and the actual computer it's connected to. So you can actually pass both the voice VLAN traffic and the standard computer VLAN traffic across a single interface. But with that small exception in place, let's talk about trunk ports. So your trunking ports allow you to pass multiple VLANs worth of traffic to another intermediate device across a single cable. A trunking port is kind of like multiplexing in a lot of ways, where multiplexing is combine multiple data streams into a single physical media. It's pretty much the same concept. So now that we have all of that out of the way, let's discuss the Dynamic Trunking Protocol DTP and the VLAN Trunking Protocol VTP. On the surface, both of these appear to be a very similar protocol. Both of these are layer 2 protocols. Both of these are Cisco proprietary protocols, and both of these exist specifically in order to help you use VLANs more effectively. However, that's about where the similarities end. When we're discussing DTP, DTP is designed for non-static networks. Now, what I mean by non-static networks is that most networks are generally static. Once you have all of your cabling configured, once you have all of your employees in place, most networks are not going to make that many changes that often. Unless you're working for a company that very often practices things like reorganizations and layoffs, once your network is wired and in place, you're not going to have to make major changes to that network very often. You might have to light up a port when you get a new employee and turn it off when that employee leaves. But other than that, your network is not going to be making major changes. However, there might be specific use cases where you might have a constantly changing network. This might be, for instance, if you have a test network where you're testing new technologies before you're actually implementing them in your live production network. You might also have research and development networks where you're constantly developing new ways of doing things, and you need to make sure that what you're going to implement is stable. Once again, a test network. This could also just be for something as simple as a classroom where you're trying to teach students how to do certain things, and throughout the semester or term, you're going to have to make constant changes to those switches. This is where Dynamic Trunking Protocol comes into play. DTP, rather than using the static access and trunk modes for a switch interface, applies two dynamic modes, dynamic auto and dynamic desirable. Now, if these terms sound familiar, that's because we talked about the same terms in my last video on defeating spanning tree protocol. However, in that video, we were discussing the port aggregation protocol, which is slightly different and is used for a very different use case. However, the terminology is the same, and both behave very similarly when you're looking at the difference between when you're talking about the difference between a desirable port and an automatic port. In simplest terms, a desirable port is a port that has the ability to either become a trunking port or an access port, but it prefers to be a trunking port. It's also going to negotiate the establishment of a connection. So if you have a desirable port on a switch, and you connect it to another switch that has its interface configured as a trunking port, that desirable port will automatically configure itself as a trunking port so you don't have to. If you connect it to a interface that is configured as a static access port, the desirable port, because it is not statically set for trunking, will automatically configure itself as an access port just in order to allow this communication to begin. Dynamic auto operates on a very similar principle with two major exceptions. The first exception is that, unlike desirable, automatic prefers to be an access port. So if you connect an auto port to a trunking port, it will come up as a trunk port. If you connect it to an access port, it will come up as an access. But if you connect it to another automatic port, it will prefer to be an access port rather than a trunking port where the desirable does. Now, both of these interfaces are fluid, and when it comes to a tiebreaker, like I mentioned earlier, if you connect a desirable port on one switch to an auto port on another, The auto port is kind of that indecisive date that can't decide where they want to go to dinner, but you know, they don't care until you recommend a place and they say, I don't want that. Might have issues here. Anyway, your automatic will always defer to the preferences of another interface, unless there is no preference stated, like if you connect an auto to an auto port. So this seems pretty useful, right? Why wouldn't we just always use dynamic trunking protocol? Well, aside from the fact that, once again, it is Cisco proprietary, it does create a major security risk, and this security risk comes in the form of VLAN hopping attacks. Essentially, if you connect a computer to a switch that has been configured to understand DTP message types, you can actually force a switch port to come up as a trunk port connected to your computer. Trunk ports by default allow all VLANs worth of traffic until you lock them down and only allow specific VLANs, allowing that bad actor to monitor all of your computer networks at once. This is an extremely dangerous situation that you do not want to be caught up in. This is why even Cisco, the people who developed this protocol, recommend that you disable DTP on interfaces that have a high risk of having rogue devices attached to them. So we've talked about VLANs, we've talked about dynamic trunking protocol, now let's talk about VLAN trunking protocol, VTP. Now, I mentioned that your VLAN tables can get pretty complicated pretty quickly, especially if you're working in a large organization. If you buy a new switch, or in most large organizations, you're buying them by the dozens or even the hundreds, you don't want to have to configure every single VLAN individually. You would rather just have these somehow automatically learn what VLANs are already in play based off what the other switches are running. This is what VTP is designed to do. VTP is a protocol that allows a device to serve as a VLAN server. In fact, these are the three VTP modes: server, client, and transparent. Generally, your VTP server is probably going to be something very central to your network, either a core switch or at the very least a distribution switch. Your server is designed to push a configuration out to another device. So say for instance, you configure your core switch first if you're developing a new network. As soon as you connect all of your distribution switches to that core switch, it's going to push its VLAN table to all those distribution switches, rather than having to configure all that VLAN information on every one of those distribution switches. They've all automatically learned that information, and once you connect all your access switches to those distribution switches, they can also learn that new information. Now, VTP does have several safeguards in place to make sure that you're not interfering with different groups of switches. For instance, they have to share a VTP domain. So if you're setting up different areas of your organization that should have different VLANs assigned to them, you can establish different VTP domains for each of those organizational areas in order for each of those switches to not share VLAN tables across those separated areas of your organization. You can also set up a password, but this password isn't overly secure and is probably something that is very easily learned. And this kind of goes without saying, they need to be on the same version. There have been multiple versions of VTP since it was developed, and so you need to make sure that all of your switches are compatible and running the same version of VTP. Now, this is extremely useful. A server is going to pass that information out, and a client is going to pull all that information. But what about transparent mode? Why would we want that? Well, one of the problems with a VTP client is you lose the ability to configure VLANs. So if, for instance, you have a small organizational unit that only exists in a small corner of your network, you can't make a new VLAN just for that particular switch because VTP co-opts your ability to change the VLAN table. There's two ways around this. You can either turn VTP completely off, which means you're not going to get updates, or you can create what's called a transparent mode, which operates very similarly to off. However, it still participates in the VTP directory. So say, for instance, that's not an access switch, it's a distribution switch. You still want all of the access switches connected to this distribution switch to receive their updates from the VTP server. A switch operating in transparent mode still sends the updates from the core switch down to the access switches, but it still maintains control of its own individual VLAN table. This is once again very useful information. However, there is a problem. VTP manages updates on a revision system. Every time you make a change to your VTP server's VLAN table, it will automatically update its revision and send those updates out. If a client receives an update, it looks at the revision number, and if it's higher than the current revision number it currently holds, then it will automatically apply this new VLAN table information that it has just received. However, if a switch receives an update but the revision number is lower than the one it already has in its VTP table, it's actually going to just throw that update away because it thinks it has more up-to-date information. So this once again opens you up to a very big problem. If a bad actor knows that you're using VTP, they have the ability to connect a rogue switch in that has a just absolute garbage VLAN table, and so long as it has a high enough revision number, it will co-opt and overwrite all of the client VLAN tables in your network. This also becomes extremely problematic if you have a device that's running in both server and client mode. For instance, you might want your distribution switches to be operating as both clients and servers, meaning that instead of all of your access switches going directly to your core for updates, your distribution switches will get their updates from the core switch, and then all of your access switches only have to go up so far as the distribution switch to get their updates, meaning you get that higher bandwidth with less network overhead in your core layer. So this becomes extremely problematic if someone introduces a rogue with a higher revision number, because not only will this overwrite all the VLAN tables in your access switches, it will also overwrite all the VLAN tables in your distribution switches, completely poisoning the VLAN tables in all of your networks. This is once again a reason why if you are going to use VTP, you need to be using passwords, and you need to make sure that that domain is something that's not going to be easily learned or guessed. DTP and VTP were both designed to make your life a lot easier, especially when it comes to constantly changing networks or brand new, freshly established networks. However, these do come with a lot of problems, and while many textbooks and cert guides discuss both of these in the same breath, these are both very different topics and both do very different things. And with that said, I think we're ready to wrap up. If you have any questions, once again, drop them in the comments below, and I'll see you here next time on Brain Melt University.